Okay, so this just says to find the critical numbers of this function, and we're going to classify them using a graph. If we want, we don't need the graph, but I guess since they want us to use a graph, it's just easier to do it that way. So you can find the critical numbers because by definition, those are just the numbers that set the derivative equal to 0. So the first thing I'll do is figure out what the derivative of this thing is. So if I take the derivative, I end up with 60x to the fourth minus 45 times 4, that's 180 x to the third minus 40 times 3, that's 120 x squared plus 0. So there's my derivative. So I have to figure out what values of x make this thing 0. It's pretty ugly the way it's written right now. So what I can do is factor out a 60x squared. So when I do that, I'm left with an x squared minus 3x minus 2. And this is the derivative. So now I'm just looking for the values that make this derivative equal to 0. So I'm going to set this derivative, I don't know why this is taking so long, equal to 0. So I have two factors. I can set the first one equal to 0. 60x squared equals 0. I get x equals 0. Or I can set the second factor equal to 0. X squared minus 3x minus 2 equals 0. Factor this. This is going to be... Oh, we can't factor this, can we? This because this is a negative. So we can't write this as negative 2 and positive and negative 1. So what we're going to have to do is use the quadratic formula here. So x equals negative b, 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 times negative 2, which is plus 8, all over, oops, this stupid thing, all over 2 times 1. So this is 3 plus or minus the square root of 17. Let me get the calculator out. So we have the square root of 17. Oops. I have 3 plus this divided by 2. And 3 minus this divided by 2. So my answers are going to be 3.562 or negative 0.5616. Let's just do 3 decimals. Negative 0.562. So what do they want us to select here? Let's go back, look at the drop-down menu for this question. Oh, I don't have this question. So it wants to just know if it's a local max, local min, or neither a max or a min. So all we have to do is we can just graph this function because they want us to use a graph. So we're going to go to y equals, and I'm going to input the graph. So we have 12x to the fifth minus 45x to the fourth minus 40x to the third plus 2. So when I do that and I hit a standard zoom, because my three x-intercepts are all relatively close to 0, so I can do a standard zoom. I can actually probably zoom in a little bit, but let's look here. I'm going to adjust the window, maybe make this a little bit more narrow in the x direction, negative 5 to 5. The y min, I'm going to try and stretch it out because I think I couldn't see the bottoms or the tops, negative 50 to 50. Oh, we got to bring that bottom down even further. Let's see here, y min do negative 200. We'll do negative 300 just to be sure. Looked like it was pretty extreme there. Oh, okay, well, let's just see if we can figure this out from the graph. I'm not going to keep plugging in values until we get the minimum there. So at x equals 0, it looks like, well, let's look at this first one, negative 0.562. Negative 0.562, if I hit trace, negative 0.562, that's right at that peak there. You might have to zoom in to see that's a peak going down like that. Actually, let's try and zoom in a little bit, shall we? Let's do negative 5 to 5, and we'll say y max is 10. Let's do 5 and negative 5. That should help. Just get an idea of what's going on there. So at negative 0.562, there we go. Okay. Trace negative 0.562. It's that peak right there. So we can say negative 0.562 is a max. And what's the next one? We have 0. And we can look at 0 here. And you'll notice that at 0, it's not a max or a min, so this is neither. We need to figure out why this is going so slow. And at 3.562, if you look at the graph, that's how we saw the graph was going down very, very far and then coming back up. So we can safely assume that that's going to be a minimum.